In this video, we're going to talk about solving applications to quadratic function equations. Okay, so let's take a look at this first example here. Notice it gives you the quadratic function equation and is asking for the maximum height. Well, one way to do this is to be able to determine what the vertex is going to be. And one way I can get the vertex is to use the axis of symmetry first. So I'm going to call this option 1. Now remember, your axis of symmetry is what? T equal to negative b over 2a. Well, b in this case is 160, and a is negative 16. So in this case, t is equal to 5. Now that's the time, but that's not telling me what the height is. So what am I going to do with t equal to 5? I'm going to plug it into the function. Okay. And when this is all said and done, this simplifies down to 408. So the maximum height is 408 feet at 5 seconds. Again, that's one way that you can do this. The second option is I can use the original function equation and to complete the square for this. So let's take a look at that option. So again, I'll rewrite this. Now, if you recall, I want to put the first two terms in the parentheses. I'll do that first. And put the constant on the outside. I need to factor out the negative 16. Okay. Now, how do you complete the square? Well, you take half of negative 10 and square it. Now, remember, it's going to be 25 on the inside, but remember, on the outside, negative 16 times 25 is negative 400, so I'm going to be adding 400 to the outside. Okay. So that is going to be rewritten as t minus 5 squared plus 408. This is now in vertex form, so you know here t is 5, okay? And the range value for that is going to be 408. Because it's asking me for the height, it's this number that I care about. So again, the max height is 408 feet after 5 seconds. Either way would be fine for this. Okay, part B then is asking us how long does it take to reach the ground? Well, if I have my particular equation, again, I'll rewrite this so we don't have to scroll back up. When it hits the ground, the height is 0. So I'm going to put in 0 for h of t. Well, thanks to part A for this, I'm just going to complete the square again. So you know, thanks to this particular step here, okay, I know that we end up having 0 is equal to negative 16 t minus 5 squared plus 408. Okay. So again, I can solve this very quickly. Subtract the 408. And divide by negative 16. Okay? So that's going to give me 25 and 5/10 is equal to t minus 5 squared. Take the square root of both sides, where that's plus or minus. And then I'm going to add 5 to both sides. Now, let's put both of these over here. Well, that ends up being about 10 seconds. Okay, and then the other one ends up being, well, that's negative. Again, we don't want the time to be negative. Okay, so in about 10 seconds, Okay? The arrow will reach the ground. Now again, if you don't want to complete the square, you certainly can do the quadratic formula in this particular step because you know A is -16, you know B is 160, and C is a quadratic formula should get you the same two answers or same two approximate answers, and you still get 10 seconds. Okay, the very last example I would like to do here is if a rectangle is a perimeter of 50 meters, then what dimensions maximize the area? Okay. So again, I'm going now, because I have to come up with my own equations for this, I'm going to write variables and what they represent. So I'm going to do L for length and W for width. Okay. Now, the perimeter for a rectangle is 2L plus 2W, and the area is the length times the width. Okay. Now, what piece of information am I given? I do know the perimeter is 50 meters. I'm going to replace P with 50. Okay. Now, eventually, I want dimensions to maximize area. The problem is I have two different variables still in this equation. So the idea is going to be I'm going to solve this equation for either L or for W, and I'm going to substitute that value into this area. So I have one equation and one variable that I can solve for. I will solve this equation here for W. So I'm going to subtract the 2L and then divide by 2. Okay. Now, the width I'm going to put into the area here. So I'm going to call this area in terms of the length. Well, that's length times now my width, which we figured thanks to the perimeter equation, 25 minus L. I can rewrite. Now, this is a quadratic equation. Okay, because you know it is L squared and it's opening downwards because the leading coefficient is negative. In this case is -1. So again, what I will end up doing is using the axis of symmetry to help me determine what my vertex is going to be. So that's L equal to -b over 2a. Now be careful, b is 25 and a is -1. So that's 25 halves. L is equal to 12 and a half. Now, I want to know what the dimensions are for the area. Okay, so I am going to go back to this equation to calculate what W is going to be. Okay, because now you know what L is. Okay, so put that in. Okay, and solve. Let's scroll down a little bit. Okay. So, dimensions of the rectangle are 12.5 feet. Usually we write the length first. It doesn't matter. Okay, are 12 and a half feet by 12 and a half feet. Or the other way, if you want to do this so that I know which is which on your paper, just put L is equal to 12 and a half feet and the width is 12 and a half feet. Okay, that would be fine with the dimensions of the rectangle arm. Okay.